Okay. Good morning, all of you. We'll start the session. So we started with the introduction in the previous class about the device management. It is the core and proprietary module in SAP Utility. Using device management, we will be in a position to create various types of devices which are connected to metering and also some devices which will aid the metering. Okay, there are two types of devices which will come into picture. The devices which are directly involved in the measurement part, okay, but sometimes we use some additional devices around these, measuring devices, okay. So normally measuring devices are called meters, okay. So we will understand by the terminology meter. So meter is a basically device, the terminology what we use in the ISU, but I device is more like a generic term, okay. Meter is a very specific term, okay. Now, you can create various types of devices in ISU, which may be directly involved in the meter reading, or maybe the certain devices which will aid in the metering device. Okay, so that is the two classification we will see. Now, basically, our goal will be here to create a particular device, okay, an equipment in the plant maintenance. And once you have this particular device created, it is identified by a unique number, which is called serial number. And then each and every device what you create has got a master record. Okay. Now this master record will contain some data as applicable to device pertaining to ISU. Okay. So one particular part of data will be ISU related data in the device master. But in addition, device is also acting as an equipment in the plant maintenance. So you are also having some data pertaining to PM module maintained in the device master. Okay. But basically, the device will evolve from the basic structure of a material master. Okay. So you can also say device equipment number is corresponding to a material. Okay. And that material has got a material master in the system. Okay. Because it's a physical material which we maintain some data for other logistics operations, like for accounting purpose or for the purchasing process, okay, or the goods receipt, okay. No need of maintaining any sales related data, but the minimum logistic data is that what we maintain in the material master. So the process here involves for creating device three stages of activity. Okay, first you create the starting point is the material master. Okay, material is identified by a unique number and we maintain all the logistic data. Using this material number, we create something in the next step, which is called the device category. Okay. So basically, device category is a non-physical, entity. It doesn't exist actually physically. Okay. But device category is basically like a template. You can say that for the certain material what we create, we extend the material not by MM01, but creating it as a device category and adding the IS related data. Okay. This IS related data primarily consists of data pertaining to a group data. Like for example, if you create device category as a meter, okay, again it is created for a particular division category, maybe electricity or water or gas. Okay, so this device category will contain certain register group data. Okay, especially when you create a meter. Okay, now apart from that, it will have some inspection data, calibration period. Okay, how the measurement will happen. Okay, some data like functional class, construction class. Okay, so that part we'll discuss. So basically, device category consists of data as applicable to several devices of the same type. Okay, so that every time I create a device, I need not enter the ISU data. It will fetch automatically from the device category. And then using device category, I can keep on creating any number of devices, and each device will be identified by a serial number, an equipment number. Okay? But the serialization can happen directly when I create device in ISU. That means there's a transaction IQ01, okay, or IQ04. Using them, I can create the devices. I also can create devices through logistics functions. Okay, like for example, whenever you perform some logistics operations, like when you create a goods receipt, okay, the serialization can happen. Okay, or when you want to issue it to certain customers, okay, the serialization can happen. So where does the serialization happen? In which particular business process? Okay, that is controlled by a sort of profile which is called serialization profile. Okay, this is generally maintained in plant maintenance, and it is used. It is a general data what applicable in regular SAP system. Okay, whenever you use plant maintenance, we are going to maintain the serialization profile, and this profile will be maintained in the material master. Okay, for example, if the material is relevant as a sales product, okay, we maintain the profile accordingly. The serialization can happen when you create a sales order. Normally, no facility is done, it is not used, but definitely serialization can happen in the goods issue. Whenever you are doing post good issue, the serialization can happen. Okay, so you know exactly what serial number of the machine is going to customer. Okay. Similarly, if it is a purchased item, okay, we can do the serialization in the purchase order or when you perform the goods receipt or goods issue. So where exactly this serialization should happen is controlled by a serialization profile. Okay? That is a mandatory field in material master. So we need to create that profile first in the system. Then we will be in a position to create the material master. Okay? To create material master, we require the industry sector and we also require material type. That part we have done yesterday. We have maintained a material type and also we have maintained a industry sector. In fact, industry sector is already there in the system. Okay? U is the industry sector, and we have created a material type by copying from ROH, and then we maintain a field reference group. Okay? So these two configurations will take care of creating and maintaining the material master. So first we will look into the serialization part. Okay, the field what we need to maintain in the material master, serial profile. Okay, so we'll go to plant maintenance module and then try to maintain a profile. So I'm going to PM module, selecting the IMG. So then we are going to plant maintenance and the customer service. And here we can select the master data in PM and the customer service. Technical objects. Okay, you can select here the technical objects. In technical objects, we have seen other day the functional location, and the next important data will be equipment. Okay, so basically, what is equipment? Equipment is kind of a machine which will give some kind of service. Okay, either that equipment is working in our plant which we are maintaining, or that equipment is actually at a customer location and for which we are giving some kind of maintenance. So select the equipment. Assign the user status profile, partner determination, field selection, allow, okay, define structure, equipment category. So first we'll go to equipment category. So number ranges are there here. We will come back and then we'll just go to profile management. So equipment category, define number ranges, equipment category, assign user status profile, partner determination. Okay. Here it is given as serial number management. Okay. So basically under the equipment, okay, under the equipment you have one separate section called serial number management. Select this. Define the serial number profile. Okay. So a profile can be created and then maintained in the system, but whatever profile you create, okay, it is applicable for what kind of equipment category. Okay. For example, whatever profile I'm creating, is it applicable to the regular MM material or is it a SD material or is it applicable to the device category, okay, or you can say ISU device. So there's the equipment category defined in the system, which will identify whatever you create equipment is a ISU device, okay. So we will maintain a profile. Ultimately, the profile will be used for maintaining the serialization for the equipment category, which is ISU device. So first we can go to define serial number profiles, select this. SAP delivers some standard serial number profiles. We can use them and then copy them and adjust, or we can also create our own serial number profile directly. So we will use an existing profile and then try to create a profile for our requirement. So you can see here some profiles are given: integrated serial number in SD, stock check, okay, HU processing, okay, stock check. So all these serial relation profiles are pre-delivered in the system. Okay, each of the profile will contain at what particular business process serialization can happen. Okay, let us say if you take in general process like material, okay, which is a purchased material. Okay, I can have some kind of provision. Okay, serialization can happen either during the purchase order, or I'll do it during the goods receipt, or I should do it during the goods issue. Okay, that means the option can be maintained for processing the material at various stages, and in one of the particular stage I want to do the serialization. Okay, maybe in one particular process I will make it as mandatory. Okay, because if everywhere it is optional, we end up not creating the serial number. Okay, but provision can also be given for serialization in one or more, the sequence of operations what to do for the material. So let us select here 0003, one of the standard, the profile what is available in the system. At the moment it is assigned to equipment category as S. Okay, S is basically customer equipment. Okay, but after copying it and adjusting, we are assigning it to I. Okay, equipment category as I. Okay, that is basically the equipment category reserved for whatever devices we are going to create in ISU. That is for ISU equipment category. Okay. So let me select first 0003 and then copy it. After copying, I will make it as ZK01. Okay. So device serialization. Okay. I'll just give some kind of identification. Device serial numbers. So I have just maintained the profile and then enter it and then copy. After adjusting, we will also assign it to the particular equipment category. Copy all and then continue. Now, if I use ZK01 in the material master, where all I can do the serialization. Okay, it may be very generic, setting, but it will also control at a particular business process where you can do the serialization. So select ZK01, okay, what we created, and then serializing procedures. Okay, so you can select here serializing procedure. So maintain goods receipt and goods issue document. That means whenever you are performing the GR or GI, serialization can happen. Serial numbers in the production order or serial numbers in repetitive manufacturing, that means it is applicable to one or more situations. Okay, if the material is SD material, serial numbers in the SD order, okay, or in the delivery, okay, or in purchasing. Okay, so it can be used as a general, sort of a, deserialization procedure. Let's assume the material is manufactured item, serialization can be done. Okay, or if it's a trading good that I'm purchasing. Okay, while purchasing also I can do the serialization. So it is kept as very open, serialization profile. Okay, but we can also make it where which particular stage it can be done. Okay, it can be none, it can be optional, obligatory, automatic. Okay, that means when I perform the goods receipt or goods issue, it can be optional. Okay, it can be obligatory, mandatory, or automatic. Okay, so depending on the requirement, we can activate one of these, the serial usage. Now, serialization numbers in the SD order or completeness check in the delivery. Let's say if I create an order for a customer, even though provision is there for serialization, I will not do it. Okay, but when I go to delivery creating, before doing the post good issue, the system will check whether your delivery is ready, okay, or is it incomplete or complete. Okay, while doing the incompleteness check, it will also check whether serialization has been done. Okay, so it can also be maintained accordingly. Completeness check for the delivery. Okay, but this we are maintaining only for the sake of material master. Okay, If you are doing the other way around, when you are doing to GR or GI, serialization can be done. But there is a provision directly to create the device also in the ISU. So in that case, the equipment category and the number range will follow automatically. Okay. Now we will just save this particular profile here, what we have created. And then this profile, we are also going to assign it to equipment category I. That means it is reserved for only devices which are created in the device management. Okay. So ZK01 is now pertaining to the equipment category ISU equipment, and then save it. Now, whenever you create a device, a number has to be assigned. So there has to be a number range. Okay. The number ranges are maintained not directly for a particular device. It is for a group of device category or equipment category. Okay. One or several equipment categories can share a particular number range, or you can maintain specifically a number range for a particular equipment category. You can follow any of them. Okay. So now, where is this particular number range is maintained? We will see that. Come back here and then go to equipment categories. Okay. Maintain the equipment category. What kind of equipment to maintain in the system? So select this. So here it is category is given here. Okay. Yes, customer equipment. At the system level, the equipment category is fixed. Okay. Either it is machines, production resource or tools, or customer equipment. Okay. Machines is basically used in PP module. Production resource and tools also used in PP module. Our machines can also be purchased items. Okay. Customer equipment will be what you use in sales and distribution. Okay. So using this equipment category, we can create one or more categories. Okay. So category classification is given already in the SAP system. Using that categorization, we can create our own category definition by maintaining a equipment category in the system. Okay. So this provision is already there. But at this point of time, we are going to use basically something called ISU equipment. You can see here, ISU equipment is a category what are given, and category number is I. Okay, so this configuration is already there. Then come back. Define number ranges. Okay, so when you create number range, normally when you create number range, either number range is directly allowed to number range object. Okay, like in the case of customer master, we create number ranges first, and then we are assigning it to the equipment, then we are assigning it to the what you call account group. Okay, like vendor master or customer master, we can create the number ranges and assign it to the basically the account number, account group. Okay, but when we take material master, okay, we are assigning it to a material type. Okay, but several material types can also share one particular number range. It is at the group level. Okay. Similarly, here in the plant maintenance also, for equipment number range, we can assign the number range to one or several equipment categories. So define the number ranges. So select the groups, change the groups. At this point of time, okay, you can see standard number range is applicable to IMPQS. Okay, that means whatever standard number range has been maintained already in the system, it is applicable to the equipment which are created with the category I or M or P or Q or S. Okay. That means number range is already defined and that has been maintained for a certain group of category of devices. Okay. It can be customer equipment, it can be plant maintenance equipment, or it can be material master equipment in MM. Okay, or it can also be a equipment category in ISU, that is I. Okay. So this is already there in the system. So existing number range you can use for the creating the devices. So we have identified a serialization profile, and then we have also maintained the equipment category, and the number range allocation has been done in the system for this particular number range. When you are also practicing in the system, the number range is already assigned to equipment category I, so you can continue to use it. That provision is already there in the system, in the IDOS. Now, we are ready with all the basic data, what is required for us to create the material. Okay, that means I have the material type, I have the industry sector, and also I have now the serial profile. Using this data, I can go and create a material master. The starting point is the device creation. Okay? So step one, we are creating using this particular data, create a basic material master for a device. Okay? For a device, let us say single rate meter. Okay, single rate meter. I'll give a description as single rate meter. So basically, it can be any kind of device. For example, it can be single rate meter. It can be for two rate meter, or it can be interval meter, or it can be a transformer, or it can be pressure regulated devices. Okay, or ARCR. So it's a general description of the material what we are creating. And once we are creating the material, we get the material number. Using this number, I'm going to create the device category. So this is the first step what I'm doing in the system. So go to MM01. Okay, I'm going to create the material master. So let us say the industry sector is U, what we have already in the system, utilities, and then material type. Okay. Yesterday you created a material type ZK01, I think, yeah, ZK01 electrical devices. Select this, select the views. What are the screens you require? We require basically basic data, which is the client level data, specific data for the plant, that is sales general plant data, and then I'm not maintaining any data like purchasing or anything at this point of time. The general plant data storage also can be maintained, and then accounting data. Okay. So basically 4 screens I've selected here for the particular material type what I'm going to use, and then we will maintain the organization levels. Okay. Whether you maintain storage location or sales organization or distribution channel, plant is the starting data. It is the most important data we have to maintain. Otherwise, basically you are going to end up creating material as only basic data. Okay, but we require valuation data, but valuation is done at the plant level. Okay, so we need to enter the plant, and then plant related data also can be maintained, like serialization profile. Of course, there are some compulsory fields like availability check group, okay, loading group, transportation group. They may not be relevant to us because they are more relevant to sales and distribution. But because these fields are mandatory, we need to maintain. So let me enter here plant as KKK and then continue. So let me say it is 401. Okay. To be more specific, I can make it also vendor specific. Siemens make single rate meter 3-phase. Okay. So I'm creating sort of a description here. Basic unit of measurement we have available here in the system, PAC. Division is not relevant here because we are not using it in the sales and distribution operation. But just for identification, we will maintain it as K1. The gross weight and net weight can be maintained. Let's say it is 1 kg. And then directly we are going to sales general plant data. Okay. Availability check group is required. I mean, if it is SD material, but otherwise also we can just maintain it as 02, individual availability check. Transportation group, not relevant to us because it is a mandatory field. I am maintaining a sort of transportation group, which is actually used in SD module for route determination. Okay. And for shipping point determination and delivery, we are using one of the loading group, 0001. But they are not related to us because we are not going to create any sales order or delivery. Only because they are mandatory, I am maintaining it here. Now, serial number profile, okay, which is mandatory field, we will enter the profile what we created just now, ZK01, devices serial numbers, and serialization level. Okay, we will say synchronize with the creation. Okay, equipment number and serial number should be serialized so that it will come in a sequence. Okay, one by one we can create the devices. It will follow a particular number range in a sequence. Okay. Now we go to finally the valuation data. So we can maintain accounting one data. Basically, it will control the account determination. So what is the valuation class here? We will select valuation class. Maybe it is available in more than one valuation class. We will just select 3000. Basically, in regular SAP system, for 3000, account determination has been maintained. So we can use this 3000. Normally, such equipment what to create, okay, are basically, the purchased items. Okay, normally they are trading goods. You don't manufacture any metering system in the production factory. Okay, so because of that, we have maintained price control as moving average. Let me give some price here, 3000 rupees, the purchase price, okay, or the valuation cost. So now I can save this particular material master. So I have created a basic material master as 401. Okay, as you have seen here, it is basically logistic data. Okay, tomorrow if I want to use it as an equipment, okay, equipment master I can create. Like yesterday I created equipment connection, I can go and create an equipment. Okay. Basically it is a serialization profile. If it is a SD material, serialization will happen in the order or in the delivery. Okay. Or if it is MM material, in the purchase order or in the goods receipt. But when you do that equipment creation, it is having only the PM data, okay, plant maintenance data, which we also require, okay. But over and above the equipment data, what is normally maintained in the plant maintenance, we have to add some data which is pertaining to ISU, okay. It is not just the equipment master. No doubt it is an equipment master, but also it should contain some data which is relevant to industry specific requirement here, that is a utility, okay. So for that, we have to now create a device category. Okay. So once we create a device category, we require the material number. Device category I cannot create directly in the system. It has to for a particular material. Otherwise, what will happen? You again create device category, again use some number range, and that particular device category has to belong to so and so material. The connection becomes very difficult, and also it may be redundant. Okay. So what SAP has done, whatever material number we have created, the same material number can be used also for device category. That means device category cannot be created directly without the material number. That is the provision in the system. Of course, there is another provision in the system which we will discuss. We can create a device category and it will ask for the material number. But suppose you have not entered any material number. What it will do, it will check the configuration and check whether in the configuration we have given any dummy material number. If you are given a dummy material number, then it will create the material master in the background, get a number, and using that number it is going to create the device category. That means either you can create device category by entering the material what you created. Otherwise, the system can create the material master in the background and use that number to create the device category. But for that you have to declare a dummy material in the system. In the client level data, when you configure in ISU, you can provide a dummy material. So that is the second option. We will see that also. Okay. Right now I'm going to create device category using the particular material. Okay. But when you create device category, certain configuration will come into picture. Okay. So that part we will see it now. And later, the most important data for creating device category is the group level data. Like in ISU, when you saw, the ISU is divided into 4 sections. What are the 4 sections? If you go to device management, we have got technology, installation, meter reading, and the inspection and sampling. But in technology, we maintain certain group data like register group, input output group, or command group. Okay, each of them are relevant to particular device category. Okay, if you create something device category as a meter, okay, then register group is compulsory. Okay, if you create device category as a transformer, then winding group is necessary. Okay, if you are creating device category as ARCR, okay, radio frequency converter, okay, then you require command group. Okay, input output group can be used in more than one situation. It's a very generic term. Okay, but without having register group, I cannot create device category which is a meter. So we need to understand what is register group and then maintain a register group in the system as a master data. Then we can create the device category. But to create device category, what configurations will apply? That we have to see first. So for that, we will now go to IMG again. Selecting IMG, select SAP Utilities, and then we are selecting here the device management. Select the device management. Under that, you can see here there is something called technology. Okay, select the technology, and then select the basic settings. Okay, select the basic settings. Define combination of basic device categories. Okay, now. So far we said we are going to create device category, okay? But we can create device category only by using a basic device category. We are using a new terminology here, basic device category. So what is this basic device category? We need to understand. Basically, when you create device category, what is this device category is for? Okay, that is the classification which is maintained at the system level by having what is called basic device category. That means I can create a device category in the easy access by using one of the basic device category. Okay, basic device categories are only defined in the system level, and we cannot create them because they are all coded. Okay, so what are the basic device category? For example, meter. Okay, it can be one basic device category. Okay, It can be a transformer. It can be another basic device category. Or it can be a pressure regulator in the case of water flow meters. Okay. Or some kind of counter. Okay. Or some kind of, the check meter, what we maintain. Okay. So in the system level, we have got some definition of basic device category. So first, let's try to understand what are the system defined basic device categories in the system. So I'm just selecting the help file to see any kind of information. Yes. Okay. Now, there are two things which you are going to combine here. One is the division category and one is basic device category. What is division category? Previously, when you created enterprise structure, we created our billing divisions. K1 is for electricity, K2 is for water, K3 is for gas, like that. Okay. Then these divisions, whatever you created, we assigned it to the basic division category in the system. Okay. In the system level, we have got division category, like 01 is for electricity, 02 is for gas, 03 is for water. Okay. That means whatever billing division category you create in the enterprise structure has to be assigned to the basic division category in the system. Then we know this division category corresponds to system level division category. So when you create a device category, basic device category, what is the division category? Is it for electricity or is it for gas or is it for water? That will come into picture. But what is the basic device category? It can be a meter. Okay. When you say meter, it is again a generic term. Okay. Meter can be used for electricity purpose. It can be used for water purpose. It can be used for gas purpose. Okay. But that is taken care by your division category. Okay. So for each division category like electricity, water and gas, I can maintain a basic device category meter. Okay. But when it comes to transformer, okay, we use certain kind of transformers sometimes in the ISU. These transformers, when you say, they are definitely only for electricity division category. Okay. We don't have any transformers in the case of water division category or gas division category. So transformers are required sometimes like current transformers, okay, low voltage current transformers or voltage transformers, okay. Sometimes we may like to use both, okay, depending on what is the measurement option what we have got in the meter. So we will see that part. So we can also create a basic division category, a basic device category as transformer, okay. It can be ripple control receiver like ARCR. It can be a remote meter, like for example, later on we're going to discuss something called interval meter, a smart meter. This meter has the capacity to record the consumptions for very small interval of time. Okay. Instead of just showing only one single number for the consumption whenever you read, it can show several readings over a period of time, recorded for a small interval of time, let's say 15 minutes, 10 minutes. Okay. These are called smart meters or interval meters. These are very much latest kind of meters what are available in the industry. They are costly, and then not all the countries have gone for interval meters, but there's a process of converting everything into a smart meter or interval meter. So it can be one basic, the device category. Corrector, pressure regulator, counter, okay. So at the system level, we are identifying what kind of, device category we are going to create by using what is called the basic device category in the system. And we are combining that with the division category for which division we are creating. Over and above, we also maintain one configuration. What are the basic device category can be combined also. For example, a electricity meter can be combined with a transformer. A water meter can be combined with a pressure regulator or a counter. Okay, so a corrector, like that. So one is what basic division categories are applicable for what basic device category, and what combinations of basic device category can also be done for a particular division. This is like a kind of a matrix which is already defined in the system, considering various scenarios, what normally comes in the business. Okay? So let's select that particular activity here. So first column is for division category. Okay? What is division category? It is system defined division category. 01 is for electricity, gas is for 02, water is for 03, district heating, like that. Okay? So now for each of this division category, okay, what are the basic device category you can maintain? You can maintain more than one. Okay, so that's why you got a sequence number here: 1, 2, 3, 4, 5. These are the options. Okay. Now each one column is pertaining to a basic device category. Okay. M is for meter, T is for transformer, ripple converter, remote meter, counter. Okay, or the other kind of device category what you can maintain. Okay. So meter can be created, transformer can be created, a remote control RC can be created. What is RC? It's a ripple converter. Okay? It is combination with ERCR. So ERCR. And sometimes you can combine a meter with RCR. Okay? Or you can combine a meter with a transformer. You can see here meter with a transformer. Okay? So what basic device category can be created for what basic division category, and what are the allowed combinations which are possible. Okay? So that part is also maintained in this particular matrix. So this is already done in the system, and we can straight away use this particular setting. Okay? So this part is done. I didn't change any data, so no. Okay? Now, as I said just in the beginning, if you want to create any device category, okay, you have to have some kind of group level data, like either register group level data or a binding group data or command group. Okay, so first in the discussion to come is register group. Okay, so first you have to maintain some configuration here for register group, and then you can use that information when you create a basic device category in the system in the easy access. Okay, but what is this terminology called register, or what is register group? Okay, that we need to explain. So before we do that, let me give a little bit of domain related information which will come into picture for the register group. Okay? Basically, the main kind of device what you use in the utility industry will be a meter. Okay? But what is the basic service it is doing? It is doing some kind of measuring the consumption. Okay? It is measuring the consumption. Now, this particular consumption is normally in an aggregated fashion. Okay? That means once the meter is connected in the grid line, okay, as electricity passes through it, it has got some kind of a counter. Okay, basically meter has got a counter, okay, register, okay, that will keep counting. Okay, what is the consumption has happened aggregated. Okay, so that means at any given point of time you see the aggregated data. Okay, that means it is not reset every month or something. Okay, you start using the meter, it starts aggregating the total consumption over a period of time. Okay, so if I know the consumption values of 2 points. Okay, 1st of March I have done the measurement, it has got some value. 1st of April I have done the measurement, it has got some value. Both are cumulative data. Now if I deduct the March consumption from the April, then I'll come to know what is the consumption which has happened in the month of April. So basically it's accumulating. Okay, but this particular meter what I'm using, especially in electricity, can be of 2 types of meters. Okay, one is called energy meter and one is called the power meter. Okay, so we are using here 2 terminology: energy meter, which is normally expressed in the units kWh, kilowatt hours. Okay, and sometimes we also use what is called a power meter. Okay, power meter will be in terms of kilowatts. Okay, so basically what is the difference? Kilowatt is basically the unit of measurement. Okay, multiplied by number of hours of usage will give us the energy meter data. Okay, but what is the basic difference between the energy meter and power meter, and why power meter will come into picture? That also you should have an idea, and also the basic measurement. What is that we are measuring? Okay, now electricity, when you start using, okay, it has got basic unit of measurement. Okay, what is the measurement? We say watts. Okay, the basic measurement is watts. Like if you purchase a bulb, okay, for your home usage, okay, then it is rated in terms of watts. Okay, say for example 60 watt bulb, okay, 100 watt bulb, okay, or if you buy a computer PC, okay, PC is going to consume some the energy. Okay, it is given as, let us say, 300 watts, okay, something like that. Okay, or if you have an equipment which you purchase, okay, appliances like for example a electrical oven, or let us say refrigerator, or a the washing machine, or big machinery. All these are related in rated capacity. What is rated capacity? When that equipment becomes on, okay, what is the initial power required? What is the power? It starts instantaneously. That is basically the power. Okay, 60 watt bulb means the bulb should be supplied with electricity not less than 60 watts power. Then only the bulb will become on. Okay, sometimes when your electricity is not regularly coming, okay, the power rating is low. Okay, or maybe one phase is not working properly, you see the light glowing very dimly. Okay, that means it is not receiving the rated power. Okay, so what is rated capacity of an equipment? Each rated capacity is basically the instantaneous power which should be supplied to the meter, which should be supplied to equipment, then it starts working. Okay, every equipment has got a rated capacity. Okay, let us say a refrigerator, it is labeled with a rated capacity. A sort of a washing machine, it is having a rated capacity. That means the instantaneous power what is required to become on, that particular equipment become on. Okay, but that equipment when it starts working, it's going to draw the electricity according to the rated capacity. Okay, now what is energy? Okay, energy and power. Power is the rated capacity. What is energy? Energy is nothing but the use of rated capacity, over a period of time, For example, I have got 60 watt bulb. Okay, this I use it for 10 hours. Okay, it's going to be 10 hours. So basically, it's going to be 600 watt hours. We're calling it as 600 watt hours. That means so much of energy has been passed into this particular meter, or so much of energy we have used from electricity supply. Okay, the supplying company, what is supplying us, has supplied us 600 watt hours. Okay, or it can also be 600 divided by 1000. 1000 watt hours is 1 kilowatt hour. So it can be basically 0.6 kilowatt hours. So this is called the energy. All the meters, whatever we are using, electricity department, they are all rated in kWh. That means at any given point of time, it will show us what is the kWh that has been utilized for running that particular equipment. Okay. But now, let us say we have got 100 watt bulb. Okay, which I have used it for 10 hours. Okay, which I used for 10 hours. So what is the total energy we have consumed? It's going to be 1000 watt hours. 1000 watt hours. That is basically 1 kilowatt hour. 1 kilowatt hour. Now let us say I have got a 1000 watt bulb. Okay, 1000 watts bulb. Then I've used it for 1 hour. Okay. In this case also, what is the total consumption? It's going to be 1000 watts hours. Okay, that is basically 1 kilowatt hour. So when you see the total consumption in both the situations, what is coming? 100 watts I'm using for 10 hours, it is 1 kilowatt hour. 1000 watt bulbs I'm using for 1 hour, it is also 1 kilowatt hour. But how the electricity department is going to charge us? Based on kWh. Okay. Now if you say my kWh is 5 rupees per kWh, even whenever you use 1 kilowatt hour, we are going to charge you 5 rupees for each kilowatt hour. Then according to our consumption here, this bulb also will be into 5 rupees, this bulb is also into 5 rupees. But that is okay for understanding the billing part. Okay, but what is the implication it is going to have on the generation part, electricity? Okay, when you are going to have a equipment which is demanding 1000 watts, okay, 100 watts, okay, we are producing electricity at that level so that instantaneously it keeps giving 100 watts, okay, and the electricity meter can run. Okay, but when you have 1000 watts equipment, a bulb, okay, instantaneously the electricity department has to produce, okay, that much of power and then supply it to the grid. Okay, but as the demand will increase, okay, so basically the power is also called demand. Okay, in first case the demand is only 100 watts. Okay, but whereas in the second case it is 1000 watts. Okay, now to produce 100 watts instantaneously, there's some cost of production. Okay, but when the demand starts increasing, what will happen? You are increasing the production level. Okay, a higher rated capacity, so the cost of production will go up. Okay, so you cannot say that for electricity department it means the same. For the customer, they may say, okay, we have consumed same kilowatt hour, you bill me according to same price. Okay, but for electricity generation department or the company, okay, both are different entities. Okay, so as the demand increases, the cost of production will increase. Okay, now if you take a factory, there may be some equipments. Okay, these equipments are all rated in a particular capacity. Now when the equipment becomes on, suppose we switch on the equipment, okay, suddenly there is a huge surge of the capacity comes into picture. It requires very huge amount of current or the energy to start. Okay, once it starts running and then it is in usage, over the period of time, after 10 minutes or 15 minutes or half an hour, it will start consuming lesser electricity or lesser energy. Okay, that means instantaneously when it starts, okay, that much of electricity has to be supplied, otherwise that equipment will not become on. Okay, so that means the electricity department has to ensure the current is produced at that level and then fed into the grid line. Okay, then only that equipment will become on. Okay, so when this particular equipment coming into picture, the electricity department should be able to produce that much of rated capacity and supply. Okay, so if you have got a 30 kilowatt machine in the factory, okay, 30 kilowatt machine, or 100 kilowatt machine in the factory, okay, each one of them, whenever they start, they require some huge current initially, or some rated capacity comes into picture. Okay, but over a period of time, are they consuming at that level? Okay, so that will be known in the usage. Okay, but generally, whatever the consumption happens for the 15 minutes continuously, that is most important. Okay, so if suppose both these machines are going to run, okay, for a minimum of 15 minutes interval, okay, then two different power ratings are coming. One is coming as 30 kW, one is coming 100 kW in the usage of 15 minutes. Okay, then when the electricity department is going to bill, they are going to build the tariff structure according to the power rating. Okay, if your instantaneous consumption for less than 15 minutes is going to be less than 30 kW, then whatever consumption you are doing, it is going to be charged at 5 rupees. Okay, but if your rated capacity, instantaneous capacity what you require for a period of 15 minutes is 100 kilowatt hour, okay, or more than 30 kilowatt hour, it is going to be charged at 6 rupees. That means we are altering the price for the consumption based on the power rating. So there has to be some kind of meter in the metering system, which will not only measure the consumption energy in terms of kilowatt hour, but also there should be a meter which will measure the instantaneous power what is demanded by the equipment and sustain for a period of 15 minutes. Okay, so either you can use a separate meter called power meter, or you can also use a energy meter separately, or some meters are coupled with both. They have the capability to the record the instantaneous power demands for a period of 15 minutes and also the regular aggregated data, cumulative data for the energy consumption. But the energy meters are all aggregated. They will keep on measuring and then aggregate and then you see. But power meters are not like that. Okay, it is for each billing period. Suppose my billing period is 1 month. Okay, so for every month there may be several instantaneous, the starting of the equipment. Okay, maybe first day when I started, instantaneous power was 20 kW. Okay, second day I started 25. Third day or fifth day when I started some machines, it was some machines may not run all the time. Okay, some machines may run only during particular production schedule. Okay, so what is the maximum power it demanded at one time for 15 minutes in the month? Okay, that will be recorded in the power meter. Okay, there may be several readings available, but system will show among the readings whatever you have one maximum instantaneous power what was demanded by the equipments in the factory sustained for a period of 15 minutes. Okay, so after you take the reading, you reset it to 0. Okay, that means next month when it's going to start reading, it's going to again record several recordings in the power meter, and then among the reading whatever it has got, it's going to show us one maximum instantaneous power that actually it is utilizing for a period of 15 minutes. Okay, so energy consumption meter, there's no resetting. It keeps on working as an aggregated way. Okay, but when you have a power meter, normally after you take the reading, we reset it. Okay, so that is one basic difference. So that every month we take fresh reading for power meter and cumulative consumption data for the energy meter. So that is one basic classification: power meter and energy meter. What is power meter? It is measuring what is the instantaneous power is demanded in the supply line. Okay, but energy meter, utilization of the energy over a period of time measured in kWh. Okay. Then there is one more terminology here what you use in electricity, which is called active energy. Okay, active energy and reactive energy. Maybe this is well explained by an electrical engineer, but somebody who is not an electricity engineer, we may not go to the depth of it. But there is something called apparent energy. One is called active energy. So apparent energy is reactive energy, and actual energy is active. Okay. Now, what is the basic difference? Suppose you use a electricity bulb. Okay, it's more like a resistive element. You got in a bulb, you got a resistor. Okay, the moment you supply the electricity, that particular resistor element is heated up. Okay, that heat will convert into light, and then we see the light around us. Okay, so there is a conversion happening in the particular equipment. But whatever electricity you are supplying, more or less everything is converted into the light. Okay, there is nothing which is holding back in the equipment. Okay, so in this case, we can say more or less whatever energy we are feeding into the bulb, okay, it's all going to be active, okay. So tomorrow when I measure the electricity, more or less we are measuring what we have supplied, okay. But when you supply electricity to certain devices, okay, when it is passing to certain equipments, like say winding machine, which are having some windings, let's say transformer is there, okay, or some kind of machine which has got some windings in that, okay. When you pass the electricity to that machine, okay, electricity is not only passing to the grid in that particular circuit, but when you measure what it will show, it will not show the complete electricity what has been supplied, but only part of it. Because what has happened, certain electricity what is supplied to the machine is actually held back in that machine, okay, because it is energizing some coils or something in the winding, okay. That means imagine I've given 100 kilowatt hour, okay, or 1 kilowatt hour into that machine, okay. When I measure, it will not show corresponding 1 kilowatt hour. It may show only 0.7 kilowatt hour or 0.6 kilowatt hour. But whereas that 0.4 has gone or 0.3 has gone, it has gone in energizing some windings, okay. Or if the machine is getting very older, okay, new machines and old machines, okay. Old machines try to hold back some electricity in their windings or in the working of that particular equipment, okay, which is going unnoticed when you do the measurement, okay. But our billing is happening on based on the measurement, okay. You are supplying 1 kilowatt hour, but actually measurement is showing only 0.7, okay, 0.8, 0.2 cannot be measured because it is lost in the winding, okay. Then electricity department is going to lose, okay. That means that 0.2 is unbilled, but electricity supply is happening for 1 kilowatt hour, but measurement is showing only 0.9, okay. You are billing for 0.9, which is going to be lost for electricity department. So whenever you have any usage, the electricity department is also concerned about what is the active energy component and reactive energy component. If you take household application like domestic house, okay, more or less whatever equipment we have got, they are more or less all based on the active energy, okay. There's nothing like windings or something like that which will hold back the energy, okay. But even then you cannot have 100% active energy measured, okay. Some amount of electricity is lost somewhere, we cannot be measuring, okay. But conveniently they can use some kind of factors, okay. So that factors can be applied to the measurement billing, and then you get some kind of correct billing as per the generation of the department, okay. But when you are having certain machines in the factory and then you're supplying electricity, you cannot be 100% sure, okay. So normally they will be interested to know what is the power factor for these machines, okay, or what is the power factor of utilization. What is power factor? It's some kind of a relative proportionate between active energy and reactive energy, okay. Total active energy divided by total energy will give some kind of power factor, okay. So power factor, if it is less, it's going to be loss for the department, okay. Whereas more or less in the household application, is power factor is 0.9 and more, okay. Or in case suppose power factor is less, you can also increase the power factor by adding some power factor correctors in the grid line, okay. But end of the day, when you are having certain machines in the factories or something industrial applications or some kind of commercial applications, okay, the electricity generation department or whoever is supplying electricity will also be interested in two components, active energy, reactive energy, okay. Active energy can be measured by the conventional meters, okay, but the conventional meters cannot measure the reactive energy which is lost in the windings, okay. So sometimes you may also have a separate meter, or in the meter itself you have got one register which is basically showing the active energy, one is showing the reactive energy, okay. Now if in certain countries, if the reactive energy is almost 30%, then I need to bill two energies separately, okay. Active energy will be separately, reactive energy will be separately. But if the reactive energy is only 20%, okay, then I can apply some factor and then multiply with the billing units, okay. So depending on country to country, the rules and regulations will change, okay. So our meter what we have can measure active energy separately or reactive energy separately, or the provision can be there in electricity which will give both the readings, active as well as reactive energy. So active energy is what is directly measurable. Reactive energy we cannot measure it by conventional meter. You require some special design for that. Some the technology will come into picture. Okay. Now this particular relationship is called power factor, active energy and reactive energy. So that is one more information we should be knowing. Now coming to register group. Okay, what is register? Okay, you can say register is like a counter. Okay, register is like a counter. If you see the conventional old meters, okay, if you happen to see any electricity meter which is old design, okay, normally you will see inside a wheel, that wheel is like a mechanical device, okay, which is rotating, okay. When the electricity is not supplying, the wheel is not rotating, it's just stagnant, okay. But that's not the situation. It will keep, rotating in a very small revolutions, okay, when the electricity is not supplied. Normally nil, you can say. Suppose my entire house is switched off, I'm not using any electricity, then the wheel is not rotating, okay. The moment you start using electricity, the wheel will start rotating, okay. But if you use more and more, then what will happen? The revolutions will increase per minute, okay. Higher the number of revolutions, higher the consumption, okay. Each revolution will result into a particular meter reading, okay. And that is what is recorded in the meter. When I see the meter reading, it is showing me the output, but that output is basically because of a counter which is working in the particular meter. And that counter is called as a register, okay. So register is a physical thing, okay. It's an element which is sitting in the meter. Of course, meter will have so many other things also, okay. But the basic mechanism of counting is done by a register. So you can say register is like a counter, okay. Now, the counters can also be more advanced, okay. Instead of having purely mechanical, it can be more of electrical kind of thing or electronic kind of thing, okay, which are more sophisticated, okay. And also the output what you see can be in terms of a LCD display, or I can use the analog, number, like very old meters, okay. We used to have 5 different small counters, small meter reading, the sections. Each one I take the reading. Some are taken clockwise, some are taken anti-clockwise, and then you declare the value, okay. But these are very old type of meters. These days, most of the what you call equipment, what we have for measurement, will show the complete value in one single line, okay. It has got 5 counters, okay, 5 sections. In that 5 sections, I read the number, okay. Each digit is 5-digit number. You can say output is in 5-digit number. So it also depends on the mechanical construction of the device, but register is the elementary factor what is working in the meter. So at this point of time, we can think like register is a part of the equipment, that is the meter, which is directly involved in the measurement. The moment you pass electricity to the line where the meter is connected, that particular counter will start working. And number of revolutions, whatever it is doing, cumulatively is doing, okay. End of the day, whatever reading you take, up to that period, what is the consumption has happened, it will show us the total value, okay. Now, when you create a device master, device category, we have to maintain technical data pertaining to register group, okay. First I said register, but now I am bringing the terminology register group, okay. So what is this register and register group, okay. Register group is basically the data applied to one or more registers which are working in a particular device, okay. Just now when I created material, I said a single rate meter, okay. We use the terminology single rate meter, okay. What is single rate meter? We have got only one value possible coming from that particular meter, okay. One particular reading, I take it, direct it from the previous reading, I know the total consumption for that particular period, okay. Let us say previous month reading is 34,000, okay. Current month reading is showing 34,700, okay. Then I can assume that, then I can say that the total consumption for the period is 700 kilowatt hour, okay. I deduct the previous one from the present one, okay. But it is one single value, okay. But if you say 700 is the total consumption kilowatt hour, okay. But can you say that it was consumed in this fashion, okay. 700 kilowatt hour divided by 30 days divided by 24 hours, okay. Per each hour it is consuming that way. It is not, no, is not correct. Why? Because as we know, if you take household application or anywhere, we don't use always electricity continuously at the same rate, okay. Maybe in morning more equipments are running, afternoon hardly anything, very few, okay. Again in the evening time use certain equipment. That means over a period of time your usage may not be same, okay. But electricity department should be ready to supply whatever current you require at any point of time, okay. In the morning, everybody will require, all the machines are working, they require the output, the input required as per that particular level of consumption, okay. That means electricity department has to produce that much of electricity and then feed it in the grid line. Then only all the machines can start working in the each of the household, okay. Afternoon, your consumption is less. That means the department can produce lesser rate and then supply. That means electricity is not something which I can produce and stock it and then supply, okay. It has to be produced instantaneously fed into the grid line, which will pass to 1000 kilometers at a very rapid, speed. Okay. Maybe the moment I generate and feed it, it may travel over a long period of time, but in a very short distance, the electricity is available at the particular distribution end. Okay. But still, what is required has to be produced. Okay. I cannot produce excess and then supply in the grid line, which will be waste. It will just come back. Okay. So it is not utilized. But at the same time, I can produce, but which is not meeting my requirement. Sometimes you see power surge is there, like in summer in India, or let us say during the festival. So many public areas, the electricity consumption will start happening. Okay. But the demand was not known to the supply point. So suddenly what will happen? The supply will be less and demand is more. So it will be switched off. Okay. It will be like cut off from the supply. Okay. So basically supply cannot be done in such a way that I manufacture and supply. It has to be instantaneously produced. So in that case, the company may be interested to measure two interval of, two registers. Okay. One is on peak registers and one is off peak register. That means the meter has got two counters. Okay. On peak measurement will happen during certain period of time when everybody demands on peak. Peak means, that is the maximum consumption happening rapidly required for all the consumers. Okay. During morning hours, let's say morning 8 to till say evening 6 o'clock or till 4 o'clock in the evening, I will say on peak. Okay. Then it may switch over to off peak. That means register, the two registers in the meter. One will measure the consumption between the on peak, and automatically switching will happen to a off peak register in the other period. So when I take the meter reading end of the month, what I'll get two results. Okay. What is the total on peak consumption which has happened in the consumption point, and what is the consumption which has happened in the off peak consumption. Then I apply two different rates. Okay. Normally on peak we will apply with a higher charge so that the customers are made to consume less. Okay. On peak consumption I'm going to charge at 10 rupees per kilowatt hour. Okay. Off peak is going to be at 6 rupees. Then normally what happens? If the consumer wants lesser bill, they tend to consume less during the on peak, and that will have a good impact on the generating companies. Okay. So a meter is having provision to measure on peak, off peak, but there has to be two counters. Okay. One counter is working in that particular period of time. Another counter will come into picture in the counting in the second time. Okay, because we cannot have one single counter doing the job. Okay, that means two registers. So when you create a device category, how many counters are there? How many registers are there? And for each register, what data will apply? Okay, is it for electricity? Is it for water? Is it for gas? Okay, what is the output you are going to measure? Is it a 5-digit number or a 4-digit number? Is it going to measure active energy or reactive energy? Okay, is the register should be proposed for billing? Okay, all these data will be maintained in the register group. So when I create a electricity as a meter, okay, a device category, I will enter the register group data. That means how many registers are applicable to that device category, and for each register, what data will apply. So whatever devices I am going to create from the device category, they will inherit the same register group data, so that I don't have to worry about register data for each and every device. Okay. So register group will come into picture, and then I need to maintain register group as a master data in the system. So when I create a device category, I will enter the register group. That means we are identifying what kind of measurement will happen, what kind of registers we are using, what data will apply to each register in the device category. So in tomorrow's discussion, first we will do a register group configuration in IMG. Okay. Based on that, I can go and create a register group in the easy access as a master data, as a technology group level data. Okay. And using that register group, I should be in a position to create the device category, what is called the device category for electricity meter. And once my device category is ready, I should be in a position to create the device itself. Okay. So in today's discussion, we are trying to see the basic concept of creating the material, the serialization profile, and some industry related terminology called energy, power, active energy, reactive energy, conceptual understanding of the register, the working part of the meter, and also some information I have given you on the register group. Okay. But configuration part we will see tomorrow, and using that configuration we will first create a register group, and then we should be in a position to create the device category. Okay. So we conclude the discussion today, and then we will continue tomorrow. Is it okay?
Yep. Thanks, Mr. Sima. Thank you.
Okay. Okay. If you want more information on this, you can just go to the web also. You can get a lot of electrical.
Muted. Unmuted.
Okay. We'll see tomorrow. Have a nice day.